Yeah, so in this webinar, we'll be going over what the wolfSSL compatibility layer is, and that's typically what's used when migrating from OpenSSL over to wolfSSL. We'll also go over building wolfSSL to replace OpenSSL, some of the configure options that can be used, and how to actually go about building wolfSSL for that use. Some simple example applications demonstrating it. Some of the example projects that we've used the compatibility layer in, and the future of the compatibility layer, where we're going with this in the future. So to start off with, what is the wolfSSL compatibility layer? It's one of the many features that we have available with wolfSSL, and it provides a means for making calls to wolfSSL's native implementations of functions that behave similar to OpenSSL's API functions. It does this with the use of macros to map a subset of OpenSSL APIs down to wolfSSL's native APIs. It also maps some of the OpenSSL structures and enums to wolfSSL implementations. As of now, there are more than 1,700 of the most commonly used OpenSSL functions available in this compatibility layer. Now, this is a subset of all of the OpenSSL APIs available, but it's the ones that we found that are most commonly used, and we add them on as we do new like open source projects or new ports from OpenSSL over to wolfSSL. And the compatibility layer with those APIs being mapped down to native wolfSSLs allows for easily switching applications that were previously designed to link and use OpenSSL over to wolfSSL. Some of the main APIs in there is going to be like the SSL layer, the EVP and bio, all of those abstraction layers. We have quite a few of those mapped over to native wolfSSL implementations. Going into a little bit of the crypto API support. So before version 3.0 of OpenSSL, they had some of the crypto API as well. We have mappings of a lot of the SHA hashing, so SHA-256. We also have some of the AES calls, so some of the lower level crypto API calls mapped. And then the higher level abstract calls, such as the EVP, used both for signing and ciphers. Those are mapped down to native wolfSSL implementations, as well as the peak key structures for private key use. What the compatibility layer does is it allows for easily migrating a project from OpenSSL to wolfSSL without making drastic modifications to the application. So you don't need to change the API in your existing application. You just need to build wolfSSL with the compatibility layer enabled, and then link that unmodified application over to the wolfSSL library instead, and include the wolfSSL header files. Here's a brief snapshot of the main header for the wolfSSL compatibility layer. It shows places where the names of OpenSSL structures get mapped to wolfSSL implementations. It also shows a couple of the main TLS API mappings. The bulk of the code mapping APIs will be located in this SSL.h file. And we set up the header files so that they'd be similar to what would be expected with OpenSSL. So you have wolfSSL / OpenSSL directory, and inside of that directory, there's quite a few different header files that are named similar to what they would have been with OpenSSL. So some of the advantages of why someone would want to even go through the process of migrating their application from linking to OpenSSL over to wolfSSL is it can make use of wolfSSL's hardware acceleration implementations. This is very useful on especially on embedded devices where we may have a hardware acceleration implementation and there's not one existing potentially in OpenSSL. Also, we have a pretty good performance on our hardware acceleration implementations. In some cases, they are as fast or even a little bit faster than OpenSSLs. That also allows for making use of TLS 1.3 implementations. So if you're stuck on an older version of OpenSSL that doesn't have a TLS 1.3 implementation, you can switch over to making use of the wolfSSL's compatibility layer, which would then allow for using TLS 1.3 implementations on an application that was written for an older OpenSSL version. It also has a reduced footprint size when switching over from OpenSSL to wolfSSL. It's a pretty extreme difference. A couple of slides later, I'll go into exactly the difference in heap usage between the two libraries to demonstrate that. And another advantage is wolfSSL is supported by engineers who work with and develop the code. If you go through our support channel or encounter any issues, it's actually all of the engineers who worked and initially developed the code will be the support people answering the question. wolfSSL is a clear licensing model. That's helpful in quite a few projects. We're dual licensed GPLv2, and then we also have a commercial license. And we own all of the IP of the library. It was written from the ground up by us. So it has a very clear licensing model. And then there's the potential to use wolfSSL FIPS. We have both a FIPS 140-2 certification and then a 140-3 in process. That covers a lot about the compatibility layer and its value when used with a project. Next is going through the steps of turning on the feature when building the library. So a lot of times when building wolfSSL, the auto tools are being used. And with auto tools, it's as simple as adding --enable -OpenSSL extra. If using some kind of IDE or some kind of other build system that doesn't necessarily use the auto tool flags, you'd have to define the macro OpenSSL_extra. Then there's the need to include wolfSSL options.h as the first wolfSSL header. This is again with auto tools. If building with some IDE or without auto tools, you would need to include wolfSSL wolfCrypt settings.h instead of the options.h. And lastly, all of the header files, as mentioned before, for migration are located under the wolfSSL OpenSSL directory. So when changing an application over to include header files in the wolfSSL bundle, you'd want to set the location over to this wolfSSL OpenSSL directory. In some cases, we do have stub functions used throughout the wolfSSL library. There's not as many stub functions, but what I mean by stub functions is they're typically set there, and they where wolfSSL behaves differently than OpenSSL. Some functions actually don't make sense to have an implementation for, but they're necessary for an application to be able to compile. So we create those stub functions just to get past the compile time when we are doing new projects where we run into that case. You can see which stub functions are being hit with the enable debug. It'll print out a helpful message that it's in a stub function. For scoping out a initial migration, we also have the macro no_wolfSSL_stub. This compiles out completely all of the stub functions, so you'd be able to find at compile time really quickly if your application is going to be hitting any of these stub functions. Additional features such as key generation and algorithms need to be controlled with enable options, where wolfSSL is very modular. Some of the features are not necessarily compiled in by default. So things like enable key gen would need to be added for adding key generation support. The alternative to using the compatibility layer, which is just the API mapping down to wolfSSL's native implementations, is to make use of either our wolfEngine or our provider. This slide is going into a little bit of detail about the wolfEngine that we have available. It was tested with wolfSSL FIPS using OpenSSL 1.02 and 1.1.1. And it's a quick fix if there's found to be too many missing compatibility APIs, where we have a subset of the OpenSSL APIs mapped down to our native ones. There's the potential that you run into a couple. With a lot of the projects that we've been doing recently, it's only been a handful of API that needs to be added, since we have so many of the more common APIs already mapped down. wolfEngine is built has built-in automated unit tests and continuous integration testing that we do. There's releases available for download that are GPL v3 or commercial. There it's up on our public GitHub repository, or you can see it down our download page. And the other side of the engines is the providers. So OpenSSL 3.0 and later will move to this provider framework. We have a wolfProvider available. It's a quick fix if too many missing compatibility APIs. And also if you have a need for FIPS immediately, we have FIPS certification, so we can be plugged in as a FIPS provider there. And it's available again for download in GPL v3 or commercial. So you can download it, test integration, test use before moving to commercial if commercial is needed. It's a public GitHub repository up on our main wolfSSL site, and then wolfSSL/wolfProvider. So it's a brief of building wolfSSL. We also went into a little bit of the alternatives to the compatibility layer. Next, we'll be going over some simple example application demonstrations. This is what you do with the library after you being wolfSSL after it's been built. So when migrating an application from OpenSSL to wolfSSL, you add the include of wolfSSL to the include path, so the app can include the header files like OpenSSL ssl.h. This is that subdirectory underneath wolfSSL where we have all of the same naming for our header files, so that they can be pulled in automatically from applications that are using our compatibility layer. The other option is switching the application from an include of OpenSSL ssl.h to wolfSSL OpenSSL ssl.h. And typically we don't do that second option. It's a lot cleaner to not have to change the include paths when porting over from OpenSSL to wolfSSL. So we just make adjustments to like the include paths where the headers are being found when it's being compiled. The next thing that has to be accounted for is just linking over from OpenSSL to wolfSSL. OpenSSL's libraries have the -L SSL and -L crypto for the two libraries that it includes. To be able to then compile an application to wolfSSL, you'd switch that over to be -L wolfSSL. Here's a couple of examples of actually going about and running the GCC compile command. So with OpenSSL at the top here, you see it's the GCC file name. output, and then linking to -l-SSL or -l crypto. And then below that, you can see an example of taking that same application without making any alterations to it, and then linking it to wolfSSL. So we have the additional include paths to be able to find the same header namings as before, and then added -include wolfSSL options.h. That just adds an include to wolfSSL options.h as the first thing when it's compiling each of the files, and that allows the application to be able to see the how the wolfSSL library was configured and match up with it. And then the last thing is the library link to here is -l wolfSSL instead of the OpenSSL versions. This is a code snippet of the example TLS server. So this example TLS server was used in the next couple of slides for collecting the actual heap usage difference between the two libraries. And you can see it's pretty standard stuff if you're used to building applications with OpenSSL. It's the main TLS and SS. Well, they call it SSL _ API. So you have the SSL read and all of the initialization and creating of the SSL object is going to be the same as what you'd expect. And then all of these APIs, when making use of the compatibility layer, then are getting mapped down to wolfSSL's native implementations. This shows the difference between heap usage between OpenSSL 1.1.1 and wolfSSL 5.6.6. There wasn't really any optimizations done in the configure line on this demonstration for either for OpenSSL's build or wolfSSL's. It's mainly just comparing the two default builds. So on wolfSSL, you can notice I just used configure --enable -OpenSSL extra, which is the base OpenSSL extra build. And to collect the information that's shown here, I used Valgrine's massive, and then the massive dash visualizer to get the pretty graphs of how much heap is being used. And the same server-tls.c was used in both cases, just linked to OpenSSL. And then, like I showed in the previous slide, it was that compile command was changed to just make it then link to wolfSSL with the exact same code. And the exact same cipher suite was used in each case, ECDHE, RSA, AES 256, GCM. And OpenSSL 1.1 with that same exact application had a peak heap usage of 202.3 kilobytes. And then in comparison, wolfSSL 5.6.6 had a max or a peak heap usage of 39.1 kilobytes. It gets even more dramatic with OpenSSL version 3.0 and later. A lot of that is the provider that they've added to OpenSSL 3.0 and later, and some of the setup that it has. But OpenSSL's 3.0.2 had a peak heap usage of 845.3 kilobytes, and on the right here, it's the same configure option used with wolfSSL 5.6.6, which is just 39.1 kilobytes. So if you're on some kind of application that's just doing cares about a single connection, it's a lot of overhead heap usage in OpenSSL versus what wolfSSL has, and that translates into how well it's going to scale. Possibly, if you have like a large server farm, it's going to be able to handle more connections with less resources being used as far as heap and memory resources. And this is a little bit of an optimized version of wolfSSL's configure. So we have what we call a small option for the SP math. And that can actually reduce the heap even more, down to 28.9. And you may be wondering, what about the performance comparison? So yeah, we're using less heap, but what if we're going extremely slower than OpenSSL for the connection? And that's not necessarily the case here. Our SP math hole has been really fine-tuned for the algorithms that are typically used in a TLS connection. So that's like the SCEP 256 with ECC and the RSA 2048 3072. The typical key sizes in our single precision implementation have been highly optimized. So performance here is going to be pretty comparable to what you would see with the OpenSSL's default build as well. And just it has the less overhead of not having a provider and a bunch of others extra cruft that's in OpenSSL. So that's the example application demonstration, how to go through actually making use of wolfSSL after it's been built for replacing OpenSSL. And next is some of the example major projects that we're used in. As I mentioned before, wolfSSL is very modular. So some of these projects have specific configure enable options with auto tools to help turn on all of the features that are necessary for the projects. A good example of that is like our engine export. We also have some configure options for the WPA supplicant, and S tunnel is another good example. There's a enable dash S tunnel with the auto tools. A few of these projects have actually been upstreamed, so the use of wolfSSL is actually maintained in the upstream open source project. And then some of them we have still in like a patch that we maintain. And for the ones that we maintain, it's on our OSP repository. So wolfSSL/OSP up on GitHub. And you can peruse through there and see actually which versions and patches that are available, and they'll have readmes for how to apply those patches, build and test. All right, this goes into a little bit what I mentioned about the enable Nginx. Full changes to Nginx can be seen on our GitHub repository. Nginx is a little bit of a special case because we have a separate repository for wolfSSL-Nginx, not just up on the OSP. But yeah, well, there's quite a few up on the OSP repository, and we're always adding more as it comes up and we see the need, or as customers ask us. All right, a little bit on how to identify missing API. There is a chance that some API calls in the OpenSSL compatibility layer are not yet implemented, since we do have only a subset of the full set of API available in OpenSSL. One of the easiest ways to tell is to enable all OpenSSL features and link against wolfSSL. There's a dash enable dash OpenSSL all configure option with wolfSSL, and that's going to enable a large amount of the OpenSSL compatibility support. And then when linking your application against wolfSSL, you'd be able to see which API are then missing, because compile time issues would pop up. For missing API, we accept feature requests. One of the other things that we do is we offer consulting to expand the compatibility layer as needed. And we've had quite a few projects in the past where they're just done with OpenSSL and want to switch over to wolfSSL. And we go through and add any of the missing API as needed. If too many API are missing in wolfCrypt, it can be used as a engine or a provider. And we've had a couple of projects in the past that went that route with an engine and provider. A little bit about the future of the compatibility layer. One of the things that we have is the wolfClue, which is our command line utility. That's something that we're going to be revamping and we expand upon as well. It's It's meant to be a drop-in replacement for OpenSSL's command line utility, so a lot of the commands are set up exactly the same. It makes it easy. You don't have to relearn a new command line interface. It's still got the same commands as what you would have learned with OpenSSL's command line utility. We add additional open source projects ports as needed with wolfSSL. So we've added quite a few API just in this last year. We've it's almost, I would say, about double of the API that we had before. I know back in like May of 2022, there was around 800. Now we're up to 1,700. Actually, a little over 1,700. So we continuously add them as needed for projects as we go. So that covers a lot about how you would go about migrating from OpenSSL to wolfSSL and how to build it. And yeah, some of the big projects that we've been used in when using this conversion method with the compatibility layer. And now I'd like to open it up to if there's any questions that people may have.
Yes, that Ian is raising a hand, so I will unmute you and then Ian can talk. Hi Ian, can you hear or can you unmute yourself and you can ask question to Jacob? And I do have another question. Ian, if you have a question, you can send us the email as well. And there's another question: does wolfSSL support CMake build system?
Yes, the short answer is yes. We've done some expansion on the features recently with it as well, and it is something that we continuously test. So we do have the CMake build support.
Okay, perfect. And there's another question: for the compatibility component, can all version of OpenSSL use it? OpenSSL 1.1.1?
Yeah, it gets tricky in some cases. We do have like the OpenSSL version. I guess that would be like an OpenSSL version macro in those header files for the compatibility layer. Typically, we don't run into issues though with different versions of OpenSSL trying to use the compatibility layer. Yeah, I haven't seen very many. A lot of times it's to the application looking for that OpenSSL version number to switch the way that they're calling the OpenSSL APIs.
And there's another question: which OpenSSL SO names do you support? How do I configure which SO name is visible within your shared object?
That I'm not as sure which SL names we support. A lot of times when I'm scoping out a new project, I don't have to necessarily deal with the SL names. It's mainly just I see which API is missing at compile time, and if there is any missing API, then add those implementations. I guess we could go into more detail about if you have a particular SO name in mind or use case. If you contact us through like our support channel or our fax at wolfSSL, we could go into more detail about like a particular SO name.
And Kevin is raising hand, so I will allow you to talk. So you can unmute yourself, Kevin. I hope that people. Okay, so Kevin, if you have a question, you can email us at fax@wolfSSL and we can answer your question. And I have another question is, are there any downside to using the compatibility layer instead of rewriting for wolfSSL?
There is a little bit of a downside. What that is with our OpenSSL compatibility layer, it does add some additional code size and some additional resource usage. If you rewrite the application from the start, or actually just rewrite the application, that is, to use the wolfSSL's native API, it kind of, in my mind, it's a little bit cleaner because it's not going through the compatibility layer, and then it also uses a little bit less resources because it doesn't have that overhead.
And there's another question. The heap usage shown audio is for only one OpenSSL/wolfSSL connection. If using 1000 connections, will we see the same difference?
That is correct. Yeah, it was just one connection, so it includes all of the setup and tear down for setting up the library to start doing connections and tearing it down. As far as heap directly per connection, if you're up to 1,000, I haven't collected that number. I imagine though that there would still be quite a difference between the two libraries. Um, but yeah, I haven't collected that number.
And another question, has DTLS 1.3 been tested against OpenSSL? OpenSSL does not have DTLS 1.3 yet?
Yeah, that's true. So one of the benefits of using wolfSSL is we have the DTLS 1.3 implementation, and actually we find it kind of hard sometimes to find other libraries that are adopting it to interop with and do interop testing. We have offered up, if once OpenSSL does get DTLS 1.3, which I saw there was some movement on that to allow for interoperability. But yeah, they currently did not have DTLS 1.3.
What are the difference in power consumption used by each library?
It's an interesting question. Yeah, and it's has a lot to do. Well, embedded developers have a lot of concern with like the power consumption. So how much power is being consumed and how quickly your battery life is going to run out. There has been some collection of how much power is being consumed by wolfSSL, and often that gets compared to embed TLS because that's more down in the embedded devices. But I can't think of off the top of my head if there has been power consumption collections by OpenSSL. With all of the extra startup and teardown, I would imagine it's significantly more.
And there's another question. Can you send an instruction how to build wolfSSL on CentOS Linux?
Yeah, contact us through the fax@wolfus.com and we can get you the right documentation or the right location to be able to compile on CentOS. As long as you have auto tools, it should be the straightforward configure and enable OpenSSL extra, then make. But yeah, we can help out with that.
And another question, how does wolfSSL do when scaling up to enterprise use?
Sure. It does quite well, and we had one large server farm. I don't know if I can mention the name, but one large server farm switching over to wolfSSL just because they used less resources. It saved them having to buy, or they could use significantly less hardware when switching over to wolfSSL just because of the resource usage difference. We've also had a pretty big web server doing stress tests on use of wolfSSL versus OpenSSL, and the stress test that the results that they were showing with this web server was that they could do about double the number of connections per second. This is just the time per connection, but double the number of connections per second as they could with OpenSSL. I believe that was 1.1.1.
And there's another question. Do you have a similar layer when application moving from embed TLS to wolfSSL?
Not that I can think of off the top of my head, no. Why I say that is I've heard it brought up a couple of times, but I don't think anything was, I can't remember off the top of my head if anything was actually implemented for it. So I'd say no.
If there's no questions, and thank you, Jacob, for hosting an informative webinar and everyone for joining the webinar. Please don't forget to follow us on Twitter at wolfSSL as well as our other socials. Thank you again and see you next week.